Now that we have seen a lot of features of Orchard and a lot of services, you may want to ask that, okay, now I know how to implement something. I probably also know how to implement something right, but I'm not sure about how to implement something fast or something that runs fast. Now, so this is about performance. Obviously, performance is not an easy topic. And in the context of Orchard, even there are a lot of aspects to it. But there is something that's, even if it's not a silver bullet, it's still quite useful in a lot of scenarios where performance is an issue, and that's caching. Well, what's caching, as everybody knows, is the practice of storing some data that's hard to compute or hard to gather with the aim of serving it to multiple users. And thus these multiple users will get some answer very fast because the answer comes from some storage, the cache, and then you can periodically update or invalidate that cache to get some fresh data. That's in a nutshell. Now in Orchard, there are various ways of caching, or even in ASP.NET. We will look at probably the simplest version of it, with the so-called business cache in Orchard. So we will use something from the module orchard.caching. And since we'll use something from the module orchard.caching, which is a module and which has features that are not enabled by default when you install Orchard, we will need to do something more, but we haven't done. And that's actually to declare a dependency on another module. Let's go back to the basics. So we actually have dependencies here, and we will add another dependency to the orchard.caching module. Commonly we keep dependencies in alphabetical order just because we need some order even here, so I've put orchard.caching in the middle. And what's in orchard.caching that's so useful for us? Well, there is this iCache service. This iCache service is again an injectable service, just as pretty much anything in Orchard, and it has some quite straightforward methods as an interface. There are actually some extension methods on top of these two that make using the caching service even easier. But what's caching about? Yeah, on a very basic level, where you put things into the cache, so you write data into the cache, and then you get that data back. That's it. The cache is some supposedly fast storage. At least it should be much faster than computing the values again. Otherwise, you don't need to use the cache. And by the way, you can also explicitly remove items from the cache, and you can clear, so wipe out the whole cache as well. The caching is, by the way, well, it's not as simple as it seems. It's simple enough if you are creating a very basic application. But if it gets a bit more complicated, then caching gets exponentially more complicated. For example, you have to really know when to invalidate cache entries. So, for example, do you invalidate cache entries by time? Will a cache entry you create be stale at one point in the future, like weather data or stock market data? Then you need to use time spans as validation. Otherwise, if it's not so simple, you need to implement some logic to invalidate or to overwrite the cache data, depending on some logic. And furthermore, there is also the question of hosting and scalability. Now, in the easiest case, your web application runs on a single computer, on a single server, in a single process. There is not much to think about. But once the traffic of that site gets more less and less trivial, or the site gets more popular, then you may need multiple servers to actually serve the traffic. And once you have multiple servers, multiple machines, you don't have a single memory for all of these servers, obviously. And that's an issue because caching most of the time uses memory because that's fast and that's fast to read, fast to write, well, compared to computing expensive stuff. But now suddenly you have multiple computers where you have the state of the cache and you have to keep that up to date somehow. We won't go into that during this course, but the main point is that if you have a performance issue, caching might be one solution or part of the solution, but if you are working on an application that's not very simple, caching in itself can be complicated. But for now, let's see how caching works. Well, let's create a controller, because that's the alpha and omega of everything. So I will add a cache controller, which will be again just a controller, and surprise, surprise, we will inject iCache service here. We will have an index method. Well, let's let it return a string, so it's easier to see what it does. And let's imagine that now we want to compute something very computationally expensive, like we are computing pi to the 100 millionth digit or something. Or we are using some very slow resource here, like we are fetching some data from a remote service that's very slow, so it takes 10 seconds to answer. But obviously we don't want our users to wait 10 seconds for a page load, yet alone for a single piece of data. So we want to cache the result and serve to multiple users. So let's imagine that this method that we have here, which will return at datetime, well, it could actually return a string. This is some very slow method. And this very slow method will be indeed slow because we will make it slow with a thread sleep. And it will actually sleep for 10 seconds. And just to make sure that we see when the cache is invalidated, when it's updated, we will return the current time. And this time I will actually use, for the sake of simplicity, datetime.utc now. And in this index method, we will use this very slow method and cache its output. So we have the cache service at hand, and if we take a look at, oh, sorry, yeah. Well, I added the iCache service, but I didn't add a reference to the orchard.caching module. So actually, an iCache service class was created here. I will remove that and add a project reference to the caching module. And now we can use the cache service. So, if we take a look at it now, we will see that there are actually multiple overloads coming from extension methods for the get object method actually, because there is also get, which is doing pretty much the same, it seems. But there is also a generic version of it that will provide you with an object of the type you actually put into the cache, because it will cast it. The same with time validation, or the same with a factory function. This is actually what we will use, because this is, well, most of the time, this is the most useful. What we will do here is that we will use a cache key. Well, let it be demo cache. And then we'll supply a factory method or a factory function that will create the value. In this case, well, we could use slow, very slow directly, since that will be the method or the function that creates the value. And we can also use some time span here for validation. Well, we could say that this is valid for, well, let's say 15 seconds. Well, obviously, you want cache entries to be valid as long as possible, as long as it makes sense in that specific use case. In this case, computing our value takes 10 seconds, and we will cache the result for 15 seconds. So for 15 seconds, every visitor that comes to our site will get the answer instantly, and it's good. And we can actually, well, we could actually return the result directly. And pretty much that's it. Let's hit Ctrl-Shift-S again. And I will now open the cache controller. Remember that it takes about 10 seconds, or it takes precisely 10 seconds to compute that's computationally very expensive datetime. So what we will see now is that it takes 10 seconds to load this page, but once we have this, it comes back instantly. So for 15 seconds, this entry will be cached. For 15 seconds, we will get the same entry back. But once the 15 seconds passes, and it's happening right now, we will need to wait for 10 seconds, and the page is now loading, to get the fresh data. And it has passed, and again, we have a new date here. So the date has switched. A good thing, again, we have instant answers. Now, this caching strategy, what we apply here, if you want to use big words, is that we cache the value on demand. The first user that wants to see that value will get the performance penalty. They will wait for 10 seconds, and everybody after that will get the answer instantly. We could also cache values in advance. So for example, we could have a background task, as we just learned, get this data in the background where nobody is waiting for it, put it into the cache with cache service.put, and on the front end, in a controller, we would just say get. Get, but without the factory. So get, and this will be a string, and that's it. Oops. So no factory function here, we just get the entry from the cache. We put the entry, we put the data into the cache in the background, and we get it out in the foreground. No user waits for it, and it's always as up to date as possible. That would be another strategy. Again, what you need to use depends on your specific use case. But do keep in mind that while caching is, well, it really looks like a simple solution to complex performance problems. And most of the time, it's also worth examining what the actual performance problem is. So maybe you can make it faster, and in the end, you won't need caching at all. But sometimes, well, you can't make it faster simply, and you will need some kind of caching. And this is one of the built-in ways in order